So now we're gonna do question number 6, and question number 6, it reads as follows. It says to us, a handyman attempts to reach the roof of a hall with a ladder 5 meters in length. Unfortunately, the ladder is too short and a new ladder will be required. Suppose that the length of the ladder needed to reach the top has to be double the distance from the foot of the ladder to the wall. Also, the angle between his current ladder and the ground will need to be equal to the angle between the two ladders, right? So this is application of trigonometry. And then we can see that on the application of trigonometry, you guys here in grade 10, you just only do 2D. You'll see as time goes by, you'll do 3D. So here we have the diagram which are presented in different triangles, and we can see that we have the wall which acts vertical to the ground, and the ground will act horizontal to the wall. So we know that between the wall and the ground will always have a 90 degrees. We'll always have a 90 degrees. So they want us to calculate 6.1 for 4 marks. They want us to calculate the value of theta. What is the magnitude of theta? So this is what is happening. You can use either triangle, I'll call it the small triangle. You can use either small triangle or the big triangle. But I can see that small triangle, it will have two unknowns, which is x and the theta. But if we decide to use the bigger triangle, we have 2x and x, whereby x will cancel each other, and therefore unknown will be theta. So that means we can use the bigger triangle to determine the magnitude of theta. So to answer question number 6.1, this bigger triangle, we're gonna use the trigonometric ratios. So remember, think of your SOHCAHTOA. Remember? So we're gonna use this big triangle, which is given by 2 theta. So we're gonna use adjacent and the hypotenuse. So which trigonometric ratio are we going to use? It's gonna be cos. We're gonna use adjacent and hypotenuse, whereby hypotenuse it is most definitely opposite to 90 degrees. That's why we needed to indicate that here we have 90 degrees so that we can know this side, it is our hypotenuse. So that means cos 2 theta. Why am I saying cos 2 theta? Because we have 2 thetas over there, we just added them, is equals to adjacent over hypotenuse. In this case, our adjacent will be x, and our hypotenuse will be 2x. Now x will cancel with x, and therefore we're gonna have cos 2 theta, which is equals to 1 over 2. Now let us solve for theta. So we're gonna say here we have 2 theta is equals to second function, or cos arc 1 over 2. So I think it's 60. So when you punch this in your calculator, make sure that your calculator is in degrees. So let's say second function, cos 0.5, which is 1 over 2, at 60 degrees. And therefore we're gonna get that 2 theta is equals to 60 degrees. And therefore we divide both sides by 2, and then our theta will be equals to 30 degrees for 4 marks, and you are good to go. This will be 6.1. Now 6.2, it says to us, hence or otherwise determine the length of the ladder should be to get the handyman to the roof. So we want to determine the length of the ladder. So now the length of the ladder to get the man to the roof, which is here at the roof. So that means we're gonna have to calculate our 2x. How much is 2x? So how are we going to calculate 2x? We won't be able to use the bigger triangle, right? Why? Because we can see that x and x will fall off, and therefore we won't be able to determine x. Now our option that we can use it is the smaller triangle to determine the x. So now x, it is adjacent to this angle, which is theta at smaller triangle, and then we have our hypotenuse again, which is opposite 20 degrees, which is given to be 5 meters. So that means we're going to use small triangle to determine x, or to make x subject of the formula. So that means in this case, we can see that we're going to use again which trigonometric ratio? Cos. So that means we're going to say cos theta of this small triangle, it will be adjacent over hypotenuse. So that means here on 6.2, we're going to say cos theta is equals to our adjacent, it is x, and our hypotenuse, remember, it is 5 meters from the smaller triangle. And therefore, remember, this is the same as cos theta over 1. We're going to cross multiply. 1 multiplied by x, it will most definitely give us x. And therefore, here we're going to have 5 cos theta. Now we managed to do our x subject of the formula. Remember, the reason why we want to calculate x is because we want to calculate the length of the ladder that should get the handyman to the roof of the wall. So that means we need to calculate 2x, which is the length of the ladder that will get the handyman at the roof of the wall. So remember, we need 2x, but in order for us to calculate 2x, we just have to calculate x first. So from this formula, we're going to calculate our x. Already, we have determined the magnitude of theta. We said that the magnitude of theta in this case will be 30 degrees. And therefore, we're going to punch this on our calculator. We're just going to say 5 multiplied by cos. Our theta, it's 30 degrees. And then our answer will be to 2 decimal places. It will be 4,33. It will be 4,33. Let me see, do we have the units? Meters. It will be meters. So you can just keep it the final answer on your calculator, because this is not your final your answer. This answer 4,33 blah blah blah. You can just keep it on your calculator because this is not your final answer, and round off the final answer. It's still fine. So now to calculate the length of the ladder we're gonna say is equals to 2x, okay? Because we know that this is the length of the ladder. Get the handyman at the top of the roof, it's 2x. So that means where we see x, we most definitely going to substitute our answer, which is 4,33, and therefore we can just say your answer multiplied by 2, and then you're gonna get 8,66. You're gonna get 8,66. What are the units? Meters. And therefore this will most definitely be our final answer. So now we jump to question number 5. So question number 5, it says to us, given f of x is equals to 3 sine x and g of x is equals to 2 cos x plus 1. So here we are given the trigonometric functions, okay? So we have the sine function, and then we have the cos function. Maybe the basic, I hope the basic is good. So we know that for sine function, we have what you call the mother graph, okay? Or we have the mother function, which is denoted by y is equals to sine x. Same applies to cos. We know that we have the mother function, which is denoted by, I'll just say z is equals to, what is this thing, cos x. So now when you look at mother graph and compare to these functions, you can actually see there are changes or transformation that has been made from the mother graph function. So now I use my mother graph function as a reference. So we can see that the amplitude of sine graph has changed from 1 to 3. So basically what you can see is that we know that the mother graph, it's a function that looks like this. And then the cycle, the whole periodic motion of this sine graph, it is complete within a period of 360 degrees. How do we see that it's complete within a period of 360 degrees? It's a complete one wavelength. If you took physics, you'll understand. So now this is the pulse or half of the wave, which is this one, and then this will be the other half of the wave, which is this one, and therefore it makes a complete revolution of 360 degrees. So that's why we say the matter graph function of a sine, it get complete with one wavelength within the period of 360 degrees. Same applies to cos. So if you have your cos function like this, remember we know that the cos function, it's a graph that looks like this. So this is the half of the pulse, which is this. This is another half of the pulse, which is this, and this is other half of the wave, which is going to be this, and this will be complete within a period of 360 degrees. So these are matter functions, and then the amplitude of the matter function will always be equals to 1, and obvious this one will always be equals to 1. And then the period divider will also be 1. The period divider is the coefficient of x. In this case, the coefficient of x is 1. So hence why our period is within 360 degrees. But if we have a function like this, say y is equals to sine 2x, whereby the coefficient of x, it is now 2. This is what we call the period divider. And therefore, our wavelength will be complete within a period of 180 degrees, whereby we're going to say 360 divided by these two, we're going to get 180 degrees. Still, this is a complete wavelength, which is a complete cycle, but it is complete within a period of 180 degrees. So the coefficient of fx, do not forget, it represents the what? They represent the period divider. So in this case, we can see that the period divider is the same. And then again, on this cos function, the amplitude will most definitely change to 2. And then this, it's a shift. We say it's a vertical shift, okay? Vertical shift. I think there was a question that we did under the trigonometric functions, whereby I said that each and every time when they say to you, determine the amplitude of the function, you need to use your formula, maximum minus minimum divided by 2, because sometimes it can get confusing. So you will always think that your amplitude, it is a number that you take from the graph. Apparently, you can just do calculation and then you will see that it will not always be the case, whereby the amplitude, you can just take it from the graph, where you just need to be careful. But we'll see about that after plotting this. Anyways, this is the mini basic that I just wanted to discuss with you. So without wasting any time, let us answer the questions then. So now they say to us 5.1, sketch on the grid provided the graphs of f and g within this interval between 0 and 360, which is most definitely going to give us a complete wavelength. So this is simple, guys. You don't even have to complicate your life. You are given the grid graph, okay? You are given the grid graph. So all you have to do is just open up your calculator. 3 sine. I know you guys also have tricks on how to use the calculator to determine all of these values. Now I'm old-fashioned. What I do is I'll type my function as it is. I'll say 3 sine. I start with 0, but make sure that you are fast. So when you substitute 0 over here, because our x over there it's 0, we get 0, right? It's 0 is to 0. But now when we substitute 30 over there, we get 1,5. When we substitute 30 here, we get 1,5. So 1,5, it is most definitely gonna be between 2 and 1, which is here. That's why we are given the grid, so that we can do things correctly. And therefore, when you substitute 60 there, we get 2, let's say 2,6, just above 2,5. So this is 2,5, and we get 2,6. I'll just put it over a little bit here. Or it's 60 is going to be a little bit here. And therefore, now we punch 90, and then when we punch 90, we get 3, which is most definitely the amplitude. We get 3. We get 3. Let me erase this so that I do not get confused. Okay, so let me just erase this. Right. So when we punch 120, just write 12 there. We get again, yes, 2 comma this, which corresponds with this one. Let me 120. I hope you guys also do the same thing on your calculators. When you get 150, I think it's gonna be 1,5. Just for safety, let's just confirm. Yes, it's 1,5. 150 is gonna be 1,5. It's gonna be 1,5. And then when we punch 180, we're gonna get 0. Sine 180 is 0. Okay, sine 180 is 0. So that means we're gonna get it here. So you can tell 210, it's gonna be again 1,5, negative 1,5. 210 is gonna be negative 1,5. negative 1,5, it's gonna be here. I hope I'm correct. Yes, it's gonna be here. And then 245 is gonna be negative 2,6. 240, it's gonna be negative 2,6. This is 2, right? This is 2,5, a little bit above 2,5. It's gonna be here. And then 270 is gonna be negative 3. 270 is gonna be negative 3. And then 300 is gonna be where is it? Negative 2,5 again. And then 330 is gonna go with this one. And then 360 is gonna be 0. You see, it's a complete wavelength. It's just that it has changed from the matter graph, it has changed with the amplitude, and therefore you just join your graph. You just join your points. And then please, when you join these points, don't draw something that looks like a crocodile there. Okay, so do proper stuff. You'll understand I'm using a highly advanced technology over here. So but I'm trying anyways. There it goes. Make sure that I want to see those curves, boys and girls. I want to see those curves. Make sure that you draw proper stuff there. I tried. So this graph is graph of F, right? So we're gonna repeat the very same procedure once more again. Let me use purple one. Now we're gonna draw this function. You'll see it's gonna shift 1 unit upwards, okay, from the paragraph. Now this function, you're gonna repeat the very same process. We're gonna say 2 cos 0 is gonna be 1 plus 1. When you substitute 0 over here, we get positive 3. This is a shift from the paragraph, okay? The amplitude was here, but it shifted 1 unit. So you'll have to understand. And therefore, we substitute 30 over there. We substitute 30. When you substitute 30, we get 2,7. So when you substitute 30, we get 2,7. This is 2. This is 2,5. 2,6. It's here. 2,7 would be a little bit above there, about 2,6. And then when you substitute 60, we get 2. When you substitute 60, we get positive 2, which is here. And then when we substitute positive 90, we get positive 1. Here's positive 1. When you substitute 120, we get 0. We get 0. When you substitute 150, we get negative 0,7. Negative 0,7. This is 0,5, right? 0,6, 0,7. I'll assume it's somewhere else there. And then when you substitute 180, we get, I think, yeah, negative 1. We get negative 1. 180 is negative 1. And when you substitute 210, we get the very same value, which is this one, negative this. Negative 7. Yeah, negative 7. And then 240, I think it's 0, right? And then when you substitute 240, it's 0, yes. And then 270 is supposed to be 1, I think. When you substitute 270, it's positive 1. And then 300, it's 2, it's supposed to be 2. And then when you substitute 300, we get 2. We get 2. 300, we get 2. And then 330, we're gonna get 1. 330, we're gonna get 2,7 again. 330 is 2,7. Let me see, this is 2,5. 2,7 will be somewhere else there again. And therefore, last one is 360. Finally, we got there. It's positive 3. It's positive 3. Right. So let us join our points. Join our curve. Join our curve. Nicely. Join our curve. And the end point. And therefore, this will be graph of G. This will be graph of G, okay? You're supposed to get something that looks like this. You can see that this is a graph, of course, from the bar graph, but you can understand that this is what I wanted to say, okay? So if they ask you to determine the amplitude of this, a lot of people, they will just take it from the graph and say the amplitude is 3. And apparently the amplitude is 2. Number one, you can sometimes, well, it's easy because you can see it on the graph. Sometimes this equation, it is not provided. You are provided with a sketch like this, and they say to you, determine the amplitude. Remember what they say to you when it gets to some things like this, even on each question, just for you to be safe. To determine amplitude, use the formula. Amplitude is equals to maximum subtract the minimum divide by 2. So maximum of this graph, the purple graph, it is positive 3. I'm just showing you it's positive 3. Subtract the minimum is the bottom one, which is negative 1. So you're gonna say negative 1 divided by 2, and therefore you're gonna get 3 plus 1 over 2, which is most definitely 3 plus 1 is gonna be 4. 4 divided by 2 is gonna be 2. You see now the amplitude is 2, it is not 3. So if you are given a sketch like this, and they want you to determine the amplitude of the sketch, use this formula instead, because you'll make mistakes. You don't understand that will be your reference. This will be your reference line. This will be like your x-axis passing here. The amplitude will be from there to there. The amplitude will be there from there, but some will fail to understand that fact. So for you to be safe, just say amplitude is equals to maximum minus minimum divided by 2. Minimum is most definitely the point at the like we have draft and the crest, the draft and the crest. So the crest will be maximum, the draft will be your minimum. Okay, I hope that was clear. So here we're just only sketching. Now 5.2.1, it says to us, write down, they don't even say calculate, write down the following: amplitude of G. Let's go back to our graph. Amplitude of G, you see, this is what I was talking about, but because it is provided in a form of equation, not only in a form of sketch, you can just take the coefficient of cos x. So we know that it is the amplitude of the function, okay? So that means the amplitude in this case is going to be 2. We are done for 1 mark. And then 5.2.2, it says to us, determine the period of f. The period of f, which f, this function. Now, if you have a look at the sketch without even using this, let's say for an example, we were not given the equation, but we were given a sketch. How do you see a period of a function? Look, you look at the wavelength. This is one wavelength. So you can see that this one wavelength, it is complete within a period of 360 degrees. You can see it here. This is half wave. This is another half wave. That means this is 360. This is where it ends. So that means the period of f, which is this graph, the blue graph, it will be 360 degrees. Easy as that. Okay. Now, for which value or values of x is g of x subtract f of x is equals to 4. Let's go back to our diagram. So we want where g subtract f, we will get 4, but we want the values of x whereby this is true. So this is what is happening. When you say g of x, we are talking about the corresponding y values. When you say f of x, you are also talking about the corresponding y values of f. So you want y of g subtract y of f, you get 4. So these are the y values, right? So if we have a look at this point, and then we say This is g of x, right? What is g of x at this point? G of x at this point, it is 3. What is, you check the very same x value, okay? So what is f of x at this point? F of x at this point is 0. So that means you're gonna say 3 minus 0, you get 3. You do not get 4, which is the solution that we want. So you're gonna locate through your graph so that we can get the correct so that we can get the correct solution. So from here, whereby x is equals to whereby x is equals to 270, we can see that g at x at this point is equals to 1, right? And then f at x at this point is equals to -3. So let's minus -3. So when we say 1 minus -3, we get +3, which is most definitely 4. So question said for 1 mark or for 2 marks, for which value or values of x is this true? Whereby when I take g, I subtract it to f, I get 4. When I subtract g, when I subtract g from f, I get 4. It is when x is actually equals to 270 degrees. This is the first solution. So that means the first solution is whereby x is equals to 270 degrees. This is true. Now let's go further to check if there are other solutions, because the statement said determine the value of values. Okay, so let us go further, and again I can see 2 marks and we have 2 lines, could be 2 solutions, but let's go to check. Is there any way where we can get the very same thing? Here I can see it's gonna be less, you just checking, we're just checking. I think that's the only solution, because here we have 3 minus that, and yeah, that is only solution, because here our x, it will be 1,5. Here it's -7, 0,7. It won't give us 4, you see. Yeah, probably you'll get 2 marks for that. You see, there is no any other solution that we can find. Here it's 3 minus 0. In fact, this is not even 3 minus. This is, in fact, it's not here, it's f at x. Here it's f at x minus g. We're supposed to use g minus f, not f minus g. So number 1, this is even incorrect. Okay, so yeah, I hope that will be one solution that we can spot out from the graph that we just draw. Okay, all right. So now the following question, it says to us, the following question, it says to us 5.3.2, f at x multiplied by z x is greater or equals to 0. So we want whereby when we multiply the y values of f to the y values of g, we get something which is above 0 or equals to 0. So remember what I say to you when it comes to questions like this: f at x multiplied by g at x, positive. How do we get positive? It's when you say positive multiply by positive, you get something which is greater than 0, right? Which is positive. Or when you say negative multiply by negative, you're gonna get something which is greater than 0, which is most definitely positive. So let's go to our solution to determine where these two graphs could be both positive or could be both negative. So when we go to our graph, we can see here, starting from here, let me just draw a line over here. This portion, we can see that our graph, both of them are positive. So if I don't care whether it's f of x multiplied by g of x or g of x multiplied by f of x, but the thing is, if I multiply my graphs at this point, I'm gonna get positive solution. Can you see that? But as we move here we have negative, and then there we have positive. So that means in this position, in this portion over here, it will not give us the correct solution that we are talking about, because here we have negative multiplied by positive, né? And therefore here they are both negative. This portion here, this portion, they are both negative, and we know that negative multiplied by negative will give us something which is greater than 0, which is positive. And then here the solution is also totally out, because here it's positive and here it's negative. So our solution will lie between here and there. So it's going to be between 0 and 120 degrees. Again, we're going to have to include those solutions. It's going to be between 180 and 240 degrees. So to give a solution to that, they say to us f multiplied by g. F supposed to be positive, g supposed to be positive. It is here. F, where is f? F, it is positive until it gets there to 0. And then, sorry, g. What is this? G. Yeah. F, it is positive, it is positive, it is positive until it gets here. G, it is positive, it is positive, it is positive until it gets here. Can we see that? So meaning this portion, it is the solution. So it's between 120 and 0 degrees. So that means we're going to say it is whereby x, it is less than or equals to, we are including 120 because they said again where it is equals to 0. We can see that at 120, if I take this, my y here is 0. 0 multiplied by positive y, I'm going to get 0. So that means it's going to be between x is less than or equals to 120 degrees, but greater than or equals to 0 degrees. We are also including 0 there. And then another interval, we can see that where is it? It's where they are both negative. So we can see that f, it is negative here. G, it is also negative. And we know that negative multiplied by negative, we get something which is positive. So that means it's between 180 and 240. And we're going to include those solutions because at some point, going to give us 0. It's between 240 and 180. So that means we're going to say it's whereby x, it is less than or equals to 200 and what? 40 and 180. 240 degrees and 180 degrees. And therefore these will be only, yes, this will be the only solutions that we can talk about. Therefore, we are done with this question.